Well, hey everybody, this is Mr. A, and this is your last topic in Algebra 1. And we're going to finish up the semester and the course with how to graph quadratic equations. And I hope one of the things that you'll find as we go through this topic are a lot of similarities on how we graph these equations with how we graphed absolute value equations back in semester 1 when we did the absolute value graphs. All right. So we get through this video here, and then we have one more quick little video after this, and we are finished with Algebra 1 and done for the year, okay? So let's get right into it. So the first thing we need to talk about here is what a graph of a quadratic equation looks like, okay? And so we do that by always starting out with the parent function of the family, which is the simplest function of the family. In this case, it's y equals x squared. So we're going to graph this first down here on this coordinate plane right here. And we're just going to do that by generating ordered pairs, something real simple. Okay, so I'm just going to plug in these values for x, -2, -1, 0, 1, and 2, plug them in, and then generate ordered pairs when I find corresponding values for y. Okay, of course, -2 squared, that is positive 4. Okay, -1 squared is positive 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay, so I generate the ordered pairs -2, 4, -1, 1, 0, 0. So I'll have a point at the origin, 1, 1, and 2, 4. All right, so we're going to go ahead and plot those right now. So I have a point here at 0, 0, 1, 1, and then I have a point at 2, 4. So right up here, and then -1, 1, and -2, 4. And if I go through here and connect these together, oh, I missed one. Try this one more time. There we go. All right, that is the general form of a graph of a quadratic equation. All right, so they're all going to be curves with the quadratic equation family. And there are different characteristics that can change, like how the curve opens upward or downward, or if it expands out the curve, or it reduces it, or at the rate at which it goes up or down, and stuff like that we're going to explore here in a few minutes. But that's the general format of one of these. So now I want to take a look at standard form real fast right here. Okay, so I have one graph down here, down at the bottom, and we're going to use this to just get some terms taken care of here real fast. So all quadratic graphs are called parabolas. Okay, so you might hear me say, well, we're going to graph the parabola now, or something of that accord. So just note that that just means we're going to graph this quadratic equation. All right, and like absolute value equations, all parabolas have a minimum or maximum value, and that occurs at the lowest or highest point of the curve of the parabola, which I have marked here on the second line, and that again is called the vertex. Okay, and then on the next line, if you notice, I have this red dashed line vertically going through the vertex, and if you notice, that line is a line of reflection, basically. I can take the left half of the parabola and fold it over, and it'd be a replica on the right side. So we're going to call this dotted line here an axis of symmetry. Okay, so we're going to dot that in. That's going to help us generate additional points on our graph. All right, so we abbreviate that AOS, so then I know that that's the graph line of axis symmetry, and then I can do some reflection and generate additional points very, very easily on my graph. All right, so before we go on, a little activity here real fast. We just want to check the format of quadratic equations. And just remember that a quadratic equation has a degree of 2, and the highest highest exponent on a variable term is 2, okay, or a squared term. So I have 4 examples here, and I just want you real quickly to determine which of these are quadratic. All right, so I'm going to pause for a moment and let you do that, and then we'll discuss them on the other side. Okay, so again, we're looking for degree of 2. So there's the degree of 2 on this one. It's the highest degree of all the terms, so A is indeed quadratic. Okay, I'm looking on B, and notice that on B, I see a 3, so then that would mean B would not be a quadratic, it would be a higher degree. Now on C, if you rewrite this so there are no parentheses, I can distribute the x to the 5, and again to the negative 2x, and I could get 5x minus 2x squared. So there's my degree of 2, so that's a quadratic, okay? And then on the bottom one, that's standard form. So there's my 2, so that's standard form. So I would say that A, C, and D are my quadratic equations, okay? All right, now, on the next few things that I show you, these are things that we would experiment with in class. You just don't have that kind of opportunity at this point to do that. So the fortunate thing is that I'm just going to tell you this information, and we're going to get right to the graphing process so we can get this stuff figured out a little more efficiently, okay? So the first thing we have to talk about is how do we know if a parabola opens up or down? So I'm going to go ahead and fill in these blanks here for you so we don't have to do this on our own. So this whole opening up or down idea revolves around the value of A, so the coefficient in front of the squared term, or sometimes the leading coefficient of a quadratic equation, okay? Basically, it's this. If A is positive, okay, which means then, of course, A is greater than 0, then our graph is going to open upward, okay? And then if A is negative, which means that A is less than 0, then it's going to open downward. So when we go to list, we're going to make a list of our information here in a few minutes. When we list our value A, I'm just going to put an arrow next to A's value so I know then whether or not I should expect the graph to open up or open down. And I don't have the graph to know. I can look at the value of A and tell automatically whether or not these will open up or down. Because if A is positive, it's going to open up, and if A is negative, it's going to open down. Okay? On the next slide, or next screen here, I'm going to show you, this is all very, very important information. So we're going to slow down here for a minute and take a look at all this. Okay, so this is how to find the vertex of the parabola, okay, that we're graphing. All right, standard form in blue underneath there where I just highlighted the vertex, okay? So basically I lay out how to get the coordinates of the vertex and how to get the equation of the axis of symmetry. And if you notice, it all revolves around this value right here, the opposite of B over 2A, all right? So if you find that value using A and B from your equation, you can get a lot of information. You can get the x-coordinate of the vertex automatically. You can get the equation of the axis of symmetry down here automatically, because those things both equal the opposite of B over 2A, okay? Just note that for the AOS, that has to be written as an equation. X equals a value, so make sure you include that x equals when you report the equation of the axis of symmetry. And then all we have to do to get the value for the y-coordinate of the vertex is we take the value opposite B over 2A, and it gets replaced for x there and there, and then we solve this for this value right here, because remember that can be replaced as y. All right, so I'm going to show you how all this works and in just a couple of seconds, okay? Because we're actually going to do one of these. I'm going to show you this technique, and then I'm going to have this go through it real fast because I have it written out, and then we'll do a couple more examples, and the story problem, we'll call this one done, okay? So, going to our first example here, we're going to graph the equation y equals x squared minus 6x. I'm going to zoom out just for a little bit here, because I want you to see this whole list of information right here, okay? Right there. I call this a list of stuff, okay? It looks like it's pretty overwhelming. It's not. It's just a way for us to organize our information before we start graphing so that I can get everything I need to get from my graph, okay? So again, the best way to do these is to stay organized and list everything possible that you can, and then it'll be a lot easier to get the graph done when it's time to do so. All right. So for this one, I'm actually going to get the list with you. All right. So you will understand how this works. So on my equation right here, I have a equals 1. There's the number in front of x squared is 1. Okay. And since a is positive, I know it opens up. Okay. B is the number in front of x. That's negative 6. C is not there. There's no value constant term at the end, so the C is 0. Okay. Now, what we're going to do next is find the opposite of B over 2A. Well, B is negative 6. Oops. Let me bring those back up here real quick. There we go. B is negative 6, so the opposite of B would be positive 6 over 2 times 1. Okay, so then 2 times 1 is 2, so I get 6 over 2, and that reduces to 3. All right, so here's what I can tell already. The x-coordinate of my vertex is 3. The axis of symmetry has equation x equals 3. Okay, so now what I'm going to do is I'm going to take this value of 3, okay, and I'm going to plug it in to my form on equation 1, and I'm going to solve for y. If I get my y-coordinate from my vertex, I can plot it. So we're going to find that out when x equals 3. All right, so I have y equals x squared minus 6x. I have y equals then 3 squared minus 6 times 3. So I have y equals 9 minus 18. And 9 minus 18 is negative 9. So I just found the y-coordinate of the vertex. So my vertex for this graph is at 3, negative 9. 3, negative 9. Okay? So I'll graph that here in just a second. Let's finish up our list first. The y-intercept. Okay, we haven't really talked about C very much yet, but the y-intercept is the point 0, comma, C. Let me change that to a lowercase c. There we go. All right, so in this case, it's going to be the point 0, 0. All right? Now, minimum or maximum value. If the minimum or maximum value, just like an absolute value equation, occurs at the vertex, okay? And it's the y-coordinate. So when I'm looking for min or max value right here, okay, I'm looking at this value right there, all right? So the min or max value this time is negative 9. Now, is it a minimum or a max? Well, it depends on if the graph opens upward or downward. And since this graph opens upward, the vertex is a minimum. So it's going to be a minimum value of negative 9. All right, let's go ahead now and start graphing this information on our graph over here. So we're going to plot the vertex. That's down here, 3, negative 9. There it is. Okay, dot in our axis of symmetry. Okay, there we go. And now we're going to start finding some different values to plug in. Okay, I need 5 points for these graphs. I need 2 points on either side of the vertex in addition to the vertex to get my 5 points. All right, how are we going to do that? Well, simply, we're just going to plug in some values for x that are close to the x coordinate of the vertex, and we're going to plug them in and get values for y, generate ordered pairs. Okay. So I'm looking at values like x equals 2 and 1, or perhaps 4 and 5 to help us out here, okay? Let's start with x equals 2, all right? So I'm going to do x equals 2 up here at the top, okay? And I'm just going to plug it in like I did for the y-coordinate of the vertex, all right? So we're going to do y equals 2 squared minus 6 times 2. Okay, and that would become 4 minus 12, and that becomes negative 8. So I'm going to have a point on my graph at 2, negative 8. So right here. All right, so here's what I want you to check out now. We don't have to do the math to figure out the value for x equals 4. All right, we're going to use a reflection to help us out with that, like we did for absolute value equations. Okay. Notice that this x value, this coordinate, is 1 unit away from the x coordinate of the vertex. That's 1 unit away. All right. So since these are symmetric about the AOS, I can make a point the same level 1 unit away on the right side. Okay. And that's going to be the point right here at 4, -8. All right. And then I'm going to do the same thing. I'm going to pick x equals 1, okay, because I'm picking numbers that are easy to work with and are close. Another thing you can pick if you want to is the y-intercept, and sometimes we will be doing that. Okay, so you could just choose to reflect the y-intercept over the axis of symmetry if you wish. Okay, you can practice that some down the road as well. So I'm going to do y equals 1 squared minus 6 times 1. I get 1 minus 6, which is -5. So I'm going to plot at 1, -5, which is right here. Okay, and so now that that is 2 units away, I'm going to go 2 units away on the other side. So I'm going to have a point at 5, -5. Okay, I have my 5 points. All I have to do now to finish up the graph is connect them all together with a curve. It's just a sketch, so I'm not worried about, how it looks. I'm just worried about if you have the 5 points plotted correctly. Okay, so there's our graph of our equation, right there. So that's the process you're going to have to do in order to get these graphed. Okay, so it'll get a lot easier the more times you practice it. All right, and once you find the vertex, it usually goes pretty quick. All right, so let's go outline the process here real fast. Let's start with just these first two. Okay, so you're going to make that list of stuff: A, B, C, opposite of B over 2A, vertex, etc., etc. All right, that's step number 1. Step number 2, once you find the vertex, you're going to plot the coordinates, and you're going to dot in the axis, dash in the axis of symmetry. Okay, and then here's where it gets a little more interesting. Step number 3, you're going to select the next value like we did. Okay, and that's really close to the x-coordinate of the vertex. All right, you're going to obtain the y-coordinate, plugging in the x-coordinate, solving for y into your equation. Okay, and then plot that ordered pair. And then you're going to reflect that ordered pair across the AOS, the axis of symmetry. Okay, like we did. Finally, repeat steps 3 and 4 for another pair of points, and then you have your 5. Okay, and you have to have 5 points on your graph. Okay, and that's how we're going to graph a quadratic equation. Now, I have 3 examples after here. I'm going to actually skip example 2, let you do that one on your own. You can check the answer key online, okay, on Canvas if you want to figure out the answer to that one. 3 and 4 have some unique things happening with them, so I want to go over some things that you might encounter when you graph on your own. So then you'd be prepared for those unique circumstances, okay? The first thing you need to note that is if your equation is not in standard form, then just rearrange the terms so they are, okay, so you don't get your A, B, and your C confused, because if those are wrong, everything else is going to be wrong. So it's important you get your A, B, and C confused, or A, B, and C correct before you advance on to this. So I have A equals 1, or A equals -3 this time. Okay, so I know that my graph is going to be opening down. Okay, and then B is -6 again, and C this time is +5. Okay, I'm going to stop for a second. I want you to try to find the opposite of B over 2A yourself, and then I will check the answer with you in just a moment. Okay, so I'm going to pause for a second, let you find that value yourself, and then we'll come back. Pausing. Okay, so the opposite of B over 2A, the opposite of -6 again is +6, okay? And then over 2A, so it's going to be over 2 times -3. 2 times -3 is -6, so I have 6 over -6. That becomes -1. All right, so the coordinates of my vertex, the x-coordinate is -1. The axis of symmetry, x equals -1. All right, and then we're going to plug -1 into the equation and solve for y. So I have x equals -1 up here. Oops, did 2 negatives. Let me change one of those out. There we go. Okay, so it's going to be -3 times -1 squared minus 6 times -1 plus 5. All right, so negative 1 squared is 1, of course, so negative 3 times 1 minus 6 times negative 1 plus 5. So I have negative 3 plus 6 plus 5. If I add those all together, negative 3 plus 6 is 3. 3 plus 5 is 8. Okay, so the coordinates of the vertex are negative 1, 8. Negative 1, 8. All right, y-intercept. Okay, this one I'm going to let you find on your own for just a minute. 0, comma c again is the format. So I'll pause for a second. You get the y-intercept for me. Okay, if you did it correctly, it should have been the point 0, 5. Okay, and then I'll help out with this one on this problem, the min or max. Since it is opening downward, we see that from right here. Okay, I highlighted the down arrow there. Then we have a max this time of 8, because that's the y-coordinate of the vertex. That means the biggest output I'm going to have for this function is the value 8. Everything else will be less than 8. All right? So let's start graphing this one now. Over here on the graph, we're going to start with the point negative 1, 8. That's right up here. Okay. Dot in your axis of symmetry. Dot dash, you know me. Okay, so there it is. And then we're going to start by doing the y-intercept this time. It's real close, so it's a nice point to graph. Okay, we're going to start here at 0, 5. So 1, 2, 3, 4, 5 right here. Okay, so that's 0, 5. That's 1 unit away from the AOS right there. So on the other side, we know we're going to be at the same level. These are symmetric. So I'm going to put a point here at 2, 5. Okay, and now all I have to do is find one more pair. Okay, pair of coordinates, ordered pairs. So let's pick x equals 1. Okay, that's close. So we'll plug in x equals positive 1 and see what we get. Okay, so I get negative 3 times 1 squared minus 6 times 1 plus 5. Again, 1 squared is 1, so negative 3 times 1 minus 6 times 1 plus 5. I get negative 3 minus 6 plus 5. Well, negative 3 minus 6 is negative 9. Negative 9 plus 5 is negative 4. Okay, so I'm going to plot the point 1, negative 4. So down here, there it is. Okay, and then go 2 levels on the other side, or 2 levels on the other side, x levels. So you're going to be at negative 3, negative 4. Okay, and you can verify this with the math. If you want to plug in negative 3 into the equation, you'll find out that also the y value is negative 4. So this all works out with the math. Okay, you can check it on your own. And we're going to go ahead and get our function graphed here. And if you notice, this one really goes downward pretty rapidly. Okay, and that's why it's been accelerated by this 3 for A. Okay, it's called an accelerator, or sometimes it's called an amplifier. The larger that number is for A, okay, the more steeper it becomes, the less value that is for A. If it becomes like a fraction or something, a proper fraction, then it's going to really spread out that curve. It's going to make it it's going to make it more flatter than all combined to get condensed together. Okay, so you'll find that out as you graph some of these as well. So there's example 3. Okay, we're going to go right on to example 4. I'm going to stop for a minute. I want you to try to find everything in the list of stuff on your own. Okay, and I'm going to pause for a minute, and then we'll go over everything together on the other side. Okay, so pausing. Okay, so if we do it correctly, A is 1, B is negative 3, C is 0. Okay, now the reason why I wanted to do this one with you is because you might have noticed that we have B as an odd number this time. Don't let that throw you off your game. You still find the vertex the same way. Okay, and I'll show you how it's still even easier to graph this. It just looks intimidating at first, but it really isn't. Okay, so the opposite of B is positive 3 over 2 times 1. And that becomes 3 halves, or 1.5. All right, and since we're graphing on here, it might be easier to use decimals, and I'm okay with that. So if it's easier to use a decimal to do the math, by all means, do whatever's easiest. Okay, fraction, decimal, whatever works best at this point. Okay, so the vertex has an x-coordinate of 1.5. The axis of symmetry has equation x equals 1.5. Okay, let's go ahead and get that y-coordinate of the vertex. So I'm going to do that up here. So I have y equals 1.5 squared minus 3 times 1.5. 1.5 squared is 2.25. And 3 times 1.5 is 4.5. When I simplify that, I get negative 2.25. All right, so we're just going to have to estimate that. Don't put a lot of effort into getting it exact. As long as your numbers are correct and your graph looks pretty close, you'll get full credit for your work. Okay, so negative 2.25, just like that. Okay, go ahead and finish our list. Y-intercept then is 0, 0. And since A opens upward, because A is positive, then we're going to have a min of negative 2.25. All right, so I'm going to pause it again for a second and let you get the graph. Start with the vertex, dash in the axis of symmetry, and then try to reflect two ordered pairs on either side of the AOS. All right, I'll pause for a second and we'll check our answer together. Okay, so we're going to zoom in real big here so we can get this plotted correctly. There's 1.5 right there. Okay, and then down here, and of course this isn't drawn to scale. Remember, I just sketched this in. So if this is, right here, if this is negative 2.5, then this blue line right above it is half of that. That's going to be negative 2.25. So I'm just going to try to get those as close as possible, like so. Okay, there's my vertex. And I will go ahead and dash in the axis of symmetry. We know it opens upward. You don't have to, since this opens upward, you don't have to dash it below if you want to. You're more than welcome to, but it's not necessary. Okay? And we're going to do the same thing we've been doing. We're just going to go ahead and plug in the integers closest to 1.5. It'll still reflect properly, so we don't have to worry about working with any more fractions if we don't want to. Okay? So I'm going to pick x equals 1, plug it in, generate an ordered pair, reflect it for x equals 2. And then we have the y-intercept, so we'll just do that one as well and we'll be done. Okay, so we'll plug in x equals 1. All right, so I get 1 squared minus 3 times 1, which is 1 minus 3, which is negative 2. Okay, so I'm going to plug in, I'm going to plot that point. So at 1, negative 2, right over here, and then reflect it over here at 2, so then we get 2, negative 2 also. Okay, and again, you can verify this with the math, okay? It works out just fine. It'd be 4 minus 6, which is negative 2. All right, we're going to plug our y-intercept there at 0, 0, and that is 1.5 units away on the left side of the AOS, so 1.5 units on the other side is x equals 3. We're going to have another point at 3, 0, okay? And again, you can plug it in, right? 3 squared is 9, 3 times 3 is 9, so it becomes 0 when you subtract. And we have our 5 points. All we have to do now is connect them together. Perfect. There's our graph, okay? So we're done. All right, I'm going to do the word problem with you, and then we're going to call this video finished, all right? And I have one little final video to look over with one little idea, and then we are done with the class, okay? So let's read over our word problem here. Okay, the function f of t equals negative 16t squared plus 80t plus 5 represents the height of a water balloon t seconds after it is launched from a slingshot. Now, if I call this balloon a ball, I apologize. Sometimes I've been doing that. Just dropped my Apple Pencil. Let me find it real fast. And while I do that, Let's look at problem A. Okay, on problem A, if you notice, I have the list of stuff here ready to go. So I'm going to pause for just a second, and you find the list of stuff, and we'll worry about then how to figure out what we need to get this problem going, okay? Okay, I'm back now. Let's go ahead and get our list of stuff here figured out. Hopefully you got that done. So I'm going to write the function up here at the top of problem A. So we have that for quick reference. So it's y equals, or I'm sorry, you could do y if it makes it easier for you. Y equals negative 16t squared plus 80t plus 5. If you want to change these to x's, you can do that as well. I don't care. It's whatever works best for you, okay? As long as the x is time, y is height, whatever works. So A is negative 16, B is 80, C is 5, okay? Opposite of B over 2A is the opposite of positive 80 is negative 80 over 2 times negative 16. So this becomes negative 80 over negative 32. You can divide by negative 16 here, becomes positive 5 halves, or 2.5, okay? Now, let's talk for a second. If I said for part A, it said determine the maximum height of the balloon, okay? Well, we should know by now that a min or max of a quadratic equation occurs at the vertex. So all I have to do is find that min or max value, which is the y-coordinate of my ordered pair, okay? And I can figure out the maximum height of the balloon, okay? How do I do that? Well, if the x-coordinate is 2.5, I'm going to plug that value into my equation, and I will solve for it and get the corresponding y value. So the axis symmetry, x equals 2.5, okay? We'll figure out the other two here in just a minute, because that'll all come into play here in just a couple of seconds. So we're going to plug in again for, you can do x or t here if you want to. It can be x, it can be t, whatever one you wish. It doesn't matter at this point, whatever one works best for you, okay? Just don't get confused with that. We have negative 16. I'll put a y out there in front, or yeah, why not? So y equals negative 16 times 2.5 squared plus 80 times 2.5 plus 5. Okay. Okay, go ahead and work through the equation and get a value for y. Okay, evaluate that. Okay, so I'm going to pause for a second and let you do that. All right, so here's what we're going to do. 2.5 squared is 6.25. So this becomes negative 16 times 6.25 plus 80 times 2.5 plus 5. Okay, and negative 16 times 6.25 happens to be negative 100. 80 times 2.5 happens to be 200. And when you add this all together, negative 100 plus 200 is positive 100. Add 5 more, you get 105. All right? So the vertex are the coordinates 2.5, comma 105. So at this point, we can go ahead and answer A, because we know now that the min or max is a max of 105 feet. So we can say the maximum height of the balloon is 105 feet. Okay, so there's A. Go back here real fast before I forget, plug in the y-intercept. It's going to be the point 0, C, which is 0, 5. Okay, and now we can do B. Now on B, it says to approximate the time the balloon is in the air. Okay, well, we can do that two different ways. You can solve a quadratic equation, if you want to, and figure out what time the balloon hits the ground, or you can try to graph it and just get an approximation, which is what we're going to do. Okay, I have my graph already set up here. Okay, and I'm going to go ahead and finish marking the y-axis. So there's 20, 30, 40, 50, 60, 70, 80, and 90. All right, so it's a quick reference. And we know that the vertex is the point 2.5, comma 105. All right, so I'm going to mark 105 about halfway above 100. Okay, if you want to put another mark above that, so you can say it's 110, you can. And then over here on the x-axis, halfway between 2 and 3, is 2.5. So if I try to align those up, I should get my vertex to be right about there. Okay, we're going to dash in our axis of symmetry. Okay, and I'm going to let you. I'm going to pause for a minute, let you try to figure out the other four pairs that we can do here. Okay, lots of possibilities. Just pick two, or just find the coordinates of two ordered pairs and reflect them over the AOS, and you can get your graph. All right, so I'll pause for a second. Okay, so here's what I would do if it were me. We know that it's the y-intercept is down here at 0, 5. Okay, so I'm actually going to put that point here. Okay, now 5, right here at level 5, at 0, 5, is x equals 0 is 2.5 away from the AOS. So if I go 2.5 the other direction, then I would be at 5. So I'm going to have another point at 5, 5. Okay? And then all I have to do is just figure out a value between 1 and 5. So 1, 2, 3, or 4. I can reflect that point. So I'm just going to pick 1, make it easy. Okay? And we'll just do the work over here. Okay? And the value would be then, it'd be negative 16 times 1 squared plus 80 times 1 plus 5. So it'd be negative 16 times 1 plus 80 times 1 plus 5. It'd be negative 16 plus 80 plus 5. Negative 16 plus 80 is positive 64 plus 5 equals 69. Okay? So if I go up to 1, a little bit under 70, just a little bit under, I will get the next point. So right here, okay? And since that's 1.5 units away from the AOS, right there, 1.5, then I'm going to go 1.5 the other direction, be at 4, so it'll be at point 469 also. You can verify this with the math. That's all I need to get the graph. Let me try that one more time here, going upward instead. I can hit it this time. Pretty good. Okay. Now, I'm going to go ahead and extend that beyond 5, just a little bit here. Okay. Because I know that the balloon's going to hit the ground after 5 seconds. Okay. So that's the answer to problem B, just a little after 5 seconds. Okay. And that's how we can figure out what time, approximate the time the ball hits the ground using a graph. I said ball, I meant balloon. Sorry, I told you I was going to do that. Okay, rewrite that part there. I got a little messy. Okay, so there we go. 2 down, 1 to go. Okay, and then for problem C, all right, I'm going to, again, start with our equation here. So I have, we'll do the one we modified, negative 16x squared plus 80x plus 5. And you want to figure out at what time is the ball, or the balloon, 65 feet in the air. So we want to plug in y equals 65, okay? And then we're going to just solve this, okay? Now, you can also get a approximation for this on your graph if you want to you can mark off 65 feet right about there, okay, and figure out that there's a place where it's 65 feet, and there's a place where it's 65 feet, okay, and just approximate those values there if you want to, okay, and get it that way. But to verify it, you can solve this equation here that I'm going to set up for you. I'm actually not going to do all the work on this one, okay? Well, you do some of the work, but I will get it set up for you. So we're going to do 65 equals negative 16x squared plus 80x plus 5. We'll subtract our 65 from each side. So I get 0 equals negative 16x squared plus 80x minus 60. Okay, and then we can factor out a factor of 4 from that, make our numbers a little bit easier to work with. Actually, negative 4, of course, make it a positive. So 4x squared plus 20, minus 20, minus 20x plus 15. Okay, and then we'll just plug these into the quadratic formula because that doesn't factor, I don't believe. So we have a equals 4, b equals negative 20, and c equals 15. And just so you remember, x equals the opposite of b, plus or minus the square root b squared minus 4 times a times c, all over 2 times a. Okay, so there is the setup. I will then go ahead and plug them in the numbers here. So I have x equals the opposite of b, which is 20, so 20 plus or minus square root of negative 20 squared minus 4 times 16. I'm sorry, that's 4, my mistake. 4 times 4 times 5. I got a little ahead of myself there. All over 2 times 4. All right, so now just solve the quadratic formula and get your two values. So if you want to pause for a second, you can pause, and then we'll meet up with the final answer. Okay, so we have 20 plus or minus the square root of 400 minus 240 over 8. So that becomes x equals 20 plus or minus the square root of 160 over 8. Okay? Now I've already gone and worked this out, approximated these on the calculator. So I know what the exact values are. I suggest you do the same at this point. You don't have to simplify that radical since we're getting decimal approximations. Simplifying the radical is not necessary at this point. Okay? We just need to know that one answer is x equals 20 plus radical 160 over 8, and the other one is 20 minus radical 160 over 8, okay? And 20 plus radical 160 over 8 becomes 4.1, and the other one, 20 minus radical 60, becomes about 0.92. Whoops, I just went on my page. Hold on just a second here. I'll bring that back down. Here we go. Okay. I'll get rid of that line. All right, so the two answers here are 4.1. Try one more time. 4.1 and 0.92. And if you look at our graph, that looks pretty close. You know, zoom in here real fast. There's 1 second, so about a little less than 1 second, and a little more than 4 seconds. So we're good. All right, so that concludes this video, and we have one more quick little video on how to tie up some connections between different forms of quadratic equations and expressions. Okay, so I'll see you there, and then once we get done with that last video, we are done with Algebra 1. Okay, so give this a try, and let me know how it goes. All right, take